welcome you here at the Technical Forum at the 19th Group Exhibit Hydrogen and Fuel Cells 2013. Please have a seat, have a free drink on the house. The topic for the next hour is Who Cares for Safety? We will start with a short presentation followed by 2 interviews. Please give a big hand for the moderator and presenter, Mr. Dr. Ulrich Schmidtchen, the board member of HySafe.
Well, who cares for safety? This is very simple. Everybody who is using hydrogen, everybody who is dealing with hydrogen has to care for safety in his own interest. But I would like to present to you an organization which cares for hydrogen safety only, which is its main occupation. And this organization is called HySafe, and I would like to show you what a nice organization this is and how much benefit you can draw from it and why this is good for you. First, a few words about why hydrogen is important at all. I think here on this joint presentation here, many people will not be surprised to hear this, but I will nevertheless spend a few minutes on this. It's about energy, it's about future energy, it's about safe energy supply, and it's also about our whole planet. You all know that we are at a turning point as far as our energy consumption and our energy supply is concerned. We have here a plot of the energy consumption from 1940 to the present and the forecast to 2100. We are somewhere here. And you see that fossil sources, they are at a maximum now and they are going down in the future. And the gap, the demand for electricity will increase a lot. And well, the difference has to be filled up by renewable powers. So we are in a transition phase now. The oil peak is already a thing of the past. We had it a few years ago. And when we don't do the switch to renewables quickly and soon, we will get into serious problems because we might have an energy gap. Okay, this is just another way to phrase the same thing. We do have a problem. We cannot continue in the future with our energy supplies as we did in the past. Okay, well, this is general knowledge, or at least should be. Even some politicians have learned it meanwhile. And hydrogen can play an important role in such an energy system of the future, because hydrogen is a good energy storage, and hydrogen is a good means to transport energy, to keep it for another time or to use it at another place. You may use it in stationary applications like heating appliances, in mobile applications like cars, and for many other purposes. However, people will do this only when this is also reasonably safe. Otherwise, you will not be able to sell this technology. Okay, how safe is hydrogen? Well, let's have a look at the chemical and physical properties. I will not go into much detail about this here. This is not a lecture on chemistry or physics. But when you look at this table, you will find a comparison of hydrogen and hydrocarbons. The hydrocarbons are natural gas, propane, and gasoline. And when you look at most of these graphics, you will find that hydrogen is somehow different. Well, it's not a hydrocarbon. It's quite easily, there is no carbon inside, so it's natural that there are differences. Does this mean that hydrogen is dangerous? Not necessarily. At least hydrogen is not more dangerous than the energy transport means which we are used to, like natural gas, crude oil, coal, uranium, and so on. And as a matter of fact, hydrogen is flammable, but when you look at the list of possible dangerous properties which substances may have, it's surprising how many dangerous properties hydrogen does not have. For example, many people will be surprised to learn that hydrogen is not explosive. You can learn it. You can read it many times in the newspapers. Hydrogen can explode. No, hydrogen cannot. Hydrogen is not unstable, like for example acetylene, which is a very common fuel gas or a common gas for cutting and welding. Well, this can decompose and this is dangerous. Hydrogen cannot. Hydrogen is not oxidizing. Hydrogen is not toxic or corrosive. You can breathe hydrogen and, well, you will not drop dead. And hydrogen is not radioactive either. And there are many other properties which hydrogen does not have. When hydrogen is released accidentally, it is no danger for the water or for the soil. And so on and so on. Yes, I would like to say a few words on this point. Hydrogen is not explosive, even though many people think. But hydrogen is really a stable molecule, the hydrogen for itself. Many people think the presence of hydrogen will automatically lead to a gas explosion. It will not. It's not so easy at all to get a gas explosion. You need three things. A fuel gas. Yes, okay, hydrogen is a very good candidate for this. But you need also oxygen, or another gas which has an oxidizing property, so which acts similarly like fluor, chlor, and so on. And these two gases must be mixed within certain concentration limits. Outside these concentration limits, nothing will happen. And you need ignition energy. Oh, the mixture in itself will do nothing. You need energy to ignite it. So these four conditions must come together, and then, well, you may, with a bit of bad luck, you may have a gas explosion. This is a great difference to explosives, like dynamite, for example. They do not need an oxidator. This is not necessary because explosives have the oxygen already in the molecule. And hydrogen is not is stable, it doesn't decompose like acetylene, for example. In other words, when you have a tank with pure hydrogen inside, you can provide as much energy as you want. There will be no reaction because no oxygen is present. Try this in a gasoline tank, you may have a problem because the empty space in a gasoline is usually full of air. And under unpleasant conditions, you may have a reaction there. Hydrogen has a very low minimum ignition energy. In other words, it's fairly easy to bring such a mixture to ignition. However, when you look at this a bit more closely, you will find that the ignition energy for such a mixture is a function of the concentration. And here you have the ignition energy plotted as a function of the concentration for hydrogen, for methane, and for gasoline. When you look at the minimum of those curves, you will find that for hydrogen it is indeed one order of magnitude lower than the others. However, most accidents happen somewhere here at the lower explosion limit. And when you compare the curves here, you will find that hydrogen and the hydrocarbons are very much in the same region. In other words, it doesn't really matter which gas you have. You will have an explosion here with these energies in any case. And the whole discussion about ignition energies and minimum ignition energies is pretty academical anyway, because the common ignition sources, like for example electrical sparks, they have an energy somewhere here, and with these ignition sources you will ignite anything. So hydrogen is also in this respect not more dangerous than other energy carriers. I would like to direct your attention to one property which is advantageous in case of hydrogen. Hydrogen is very light. The density of hydrogen is about 1/14 that of air. Natural gas is also lighter than air, but it has already half the density of air. And propane, for example, is 50% denser than air. What does this mean? Well, in case of an accidental release of hydrogen gas, you will get rid of the hydrogen gas very quickly because it has a strong buoyancy and will rise upwards. And most ignition sources are, well, naturally they are at near the point of release or near the ground, but when you go up, there is usually no ignition source. Unlike, of course, you are in a building. but many accidental releases happen in the open. Okay. So I could show you more slides and more data and more figures and more graphics about hydrogen safety, but I'll rather talk to a real man, Mr. Thomas Jordan. Mr. Jordan, we know each other rather well, not only because we are both board members of HySafe. We do this only for fun. But we are also involved in the field of hydrogen safety professionally. You at KIT, me at BAM. And well, so you are somebody who knows something about the field. And what is your impression about the dangers associated with hydrogen?
Well, first of all, I'm heading a small group effectively dealing with hydrogen safety on a daily basis. So we come from a nuclear background. Everybody has seen hydrogen exploding in Fukushima. This was a similar accident or a similar reaction as happened also in Chernobyl and the other large-scale nuclear accidents. So this is actually our roots, where we come from, and try to understand how to, well, mitigate these reactions. Again, hydrogen is a fuel gas and has, of course, the potential to burn. This is why we use it, or want to use it, actually. On the other side, there are many ways to intervene these processes, which have been shown by Mr. Schmidtchen. You have to have a release of the gas from its vessel. This is the first point. Then you have to mix it into air, typically. Then you have to ignite it, and then the flame which starts has to accelerate. This is one of the specific qualities of hydrogen, that the flame is quite fast. This is, I would say, the main safety feature of hydrogen which is adverse or negative. So we try to prevent fast flames because these generate huge pressure, which is commonly named an explosion. So there's not a precise definition of explosion, but if you have a pressure accompanying the combustion process, then typically it's called an explosion, the big boom. So we try now to understand why a flame accelerates and how it accelerates, and we try to mitigate these accelerating processes. Though there are many ways to intervene. You can ventilate the system actively or passively. You can choose different paths to mitigate this system. So I would call this the main disadvantage of hydrogen, that it promotes fast flames. On the other side, there are nice features of hydrogen because, for instance, secondary fires, if you have a steady flame of hydrogen, it doesn't really favor secondary fires as you have them with a classical carbon, hydrocarbon flames. So, well, coming back to the question, is hydrogen safe or not, or how do we experience? So hydrogen is not safe or unsafe. Your way to treat hydrogen is safe or unsafe. Because most of the things which have been mentioned by Mr. Schmidtchen are known. It's known, the ignition properties of hydrogen are known. So you have to have a system which accounts for these specific qualities. Furthermore, hydrogen is a well-known quantity in industry. Industry uses hydrogen since a long time on a regular basis and in huge amounts. So in industry environment, hydrogen is a well-known material, and industry knows how to treat hydrogen safely. But what we plan here in this special area is to transfer hydrogen into the private customer environment. And this is slightly different than in industry, because there are people which are not trained to deal with hydrogen on a daily basis. There are people who are really intentionally maybe misuse systems, like we see in the natural gas applications at home. So furthermore, for these new innovative applications, we leave the classical thermodynamic property fields which are used in industry processes. So we go for 700 bars. We go for maybe liquid hydrogen distribution pathways. And both are actually new, innovative systems which we have to use. And there we need to have a careful study of these technologies, that they are safe. We have to prevent major incidences, which are maybe not very dramatic, but people are very carefully looking at innovative things, whether they really bring this advantage. And this is why I think we have to prove that these technologies are as safe as existing technologies. So and this is the task which we face.
So in other words, when you introduce a fuel gas, you cannot reasonably complain that it burns, no?
True.
But it can be handled, and it is being handled.
Well, the issue is that we are used to energy carriers in our daily life. So we are used to handle 220 volts, although they are, a deadly, a really mortal thing, but we have them at home. We have methane or natural gas at home, and we have actually regular accidents. Not only here in Europe, worldwide, there are regular accidents happening with natural gas.
We have here photos of elderly ladies and teenagers filling up hydrogen cars.
Yeah.
And on your institute ground,
yes.
You are building a hydrogen filling station.
Yeah.
What is your experience with it?
Well, the fact is that if you look at these pictures, although these nozzles and these look a little bit not so handy like a liquid refueling, but in fact it's a very safe and routinely done exercise. We have in Germany, I think, about 200, worldwide, we have about 200 refueling stations, which are partially in these industry environments, and some of them, a few of them, are in the public. We never had, let's say, serious events there, and these technologies are designed to be handled by usual people who are not trained to do it. And you can see even a child can refuel.
Even politicians do it.
Yeah, they like to do it. We plan to have a hydrogen bus, a fuel cell bus shuttle service in our campus. KIT, Karlsruhe Institute for Technology, was a merger of the former research center and the former university. Both sites are located in a 15-kilometer distance, and we have a shuttle service which will be served beginning from next week with 2 fuel cell buses. So we had to build up a refueling station which is able to serve these 2 buses. And honestly, the major difficulties we faced were linked to battery systems, and to other secondary systems. The hydrogen technology which we use is a very well-established technology. We have a membrane compressor there. We have a huge gaseous storage system there. This is known technology for a long time. This is nothing exceptional, and we didn't expect specific safety issues there, and we didn't see them so far. And we want to operate this service for about 4 or 5 years. The main interest is to see how the public will perceive this very efficient transportation. We have indication from other partners that these buses will be 30% more energy effective than diesel or gasoline hybrid bus system. So we have quite reliable data there already. So this.
So should you ever come to Karlsruhe in the near future, drop in on Mr. Jordan, go visit him, and if you come with a hydrogen bus, he will be happy. Yeah, for sure. And we would also like to show you then innovative solutions. You know that if you drive such a topic like hydrogen, you are faced with a necessity for innovation, because these technologies have to
match the performance of the existing technologies and have to be better. Otherwise, nobody will use them. Also in the safety performance. And we are keen on showing you what we do there at KIT, not only in KIT, all the members of HySafe are quite open guys. Although safety communication is in some places a little bit delicate, and you have to be careful, of course, how to translate the findings into something which is perceived correctly.
Thank you very much.
Yes. You're welcome.
So are you in Karlsruhe? Yes, very well. Hydrogen is a nice thing. Hydrogen is useful. Hydrogen is also safe. And okay, here I could finish my presentation, but I promised you to tell you something about what HySafe is doing to this end. What is HySafe? Well, we expect that hydrogen will be introduced as an energy carrier, as a sustainable energy carrier, and also as a safe energy carrier. Because if it were not safe, and if it wouldn't be possible to convince the public that it is safe, nobody will ever buy it, and in this case it will not be introduced at all. And the mission of HySafe in this context is to facilitate the international coordination, development and dissemination of hydrogen safety. We want to be the focal point for hydrogen safety research, education and training, or in other words, the information switchboard on hydrogen safety. And we do this on a global basis. Our association was founded in 2009 in Brussels. The origin of the whole activity was a project funded by the European Union, a networking project on hydrogen safety, which had the idea was to bring the partners together. But there were not only European partners in the project, others as well. And at the end of the project, everybody said, well, this is a very good thing and it's a very useful thing. And it would be really a pity to simply stop everything and drop everything only because the funding is gone. We carry on. And so we funded this international association. This was done in Brussels under Belgian law, and Brussels is also the legal seat of the association, but we have members in Europe, in North America, in East Asia, and we are aiming at having members in Australia and South America and in other parts of the world as well. What is HySafe doing? Well, for example, we are organizing a conference, an international conference on hydrogen safety, which is our most important activity. This conference is held every other year. The first was held in Pisa in Italy in 2005. The last was held in San Francisco in USA 2 years ago. Here you see the participants. And the next will be held in Brussels in September of this year. I expect to see you all there. And 2015, it's not yet finally confirmed, or is it meanwhile? Not yet quite, but we are very confident to have the conference in 2050 in Japan. Of course, letting people know about hydrogen safety and facts and fiction and so on, this involves education and knowledge dissemination. We have repeatedly made courses for experts, and also not only for experts but also for people who were not yet experts, and provided them knowledge about hydrogen safety. This has frequently been done in conjunction with other major events like conferences. For example, these two courses here, they were done in conjunction with international conferences. This year was done with our general meeting of members. And, well, these courses were pretty successful. People who were not so acquainted with hydrogen safety, they got a lot of knowledge from which they could proceed. Yeah. Another point is hydrogen safety has a lot of side topics, and it is very important to come to some understanding about the coordination of research priorities. And here also we make meetings and seminaries where people discuss which are really the most important points, which should be done now and what could be done in the future. And here is one of which was always very useful to get an overview of where are we and what are the important points now. And one of our ideas for the midterm future is also to publish an own international journal on hydrogen safety. We aren't yet so far. For the moment, we are cooperating with the International Journal of Hydrogen Energy, which is the leading magazine in this field. And we publish a special issue occasionally with topics only on hydrogen safety. Well, this is where we are now, and we will see where we go from there. It depends, of course, whether we get enough papers on this topic. The whole thing is not only just an academical discussion, but energy supply is something which involves the industry. And so we must address the industry needs. We must start doing this now, because hydrogen is no longer a theme for the academics and for the laboratory. Hydrogen is entering the marketplace, entering into markets where it has not been before. Of course, it has been in the chemical industry for more than 100 years, but now it is entering the places where it was not now. And this means questions like these, they all come up. They either come up new or they come up in places where they didn't come up before. And we must care for them and also tell the people what this means. We also learn from accidents which did happen, and we are either having our own databases or we are cooperating with other databases in order to provide the people who want to apply this with data about what can go wrong and what can be done against it. And finally, standards are an important thing, because hydrogen energy is a global business. Hydrogen energy is also global. Just look around on this presentation here. And the standards which may make all the things fit together, they must be global as well. It would lead us nowhere if every country would make its own hydrogen standards. So this is essentially done in the framework of ISO, the International Standards Organization. They have a technical committee, Hydrogen Technologies, and they do a lot of work also in conjunction with other committees which are dealing with specific applications of hydrogen, like, for example, cryogenic vessels, gas cylinders, or others. HySafe has now formed a formal partnership with this committee. We have a seat and a voice there, and we are very happy to contribute to the development of the field in this way. Yes, and who could tell you about HySafe better than the president of HySafe? I would like to introduce Mr. Chuvelev from Canada to the platform. And
good morning, everyone. Thank you for the introduction, Mr. Schmidtchen.
You are the president of HySafe. Yes. Well, just tell me why. What was your personal motivation to get involved into this business?
Right. I'm in this business for 30 years, and originally working as my good friend and colleague Thomas, the roots are in nuclear industry, and working in different areas of hydrogen technology, specifically in electrolysis. And then at one point I realized that hydrogen safety issues and standardization are extremely important for the successful commercialization of these technologies. So my motivation, personal motivation, actually is expressed in a vision of the association, which is to see the hydrogen introduction as a sustainable and safe energy carrier. We use the word safe or safety during this presentation quite a number of times, but this is a technical forum, so it's probably appropriate to put the safe and safety kind of in a technical term. When people say when they feel safe, essentially they communicate that they are comfortable with whatever they are talking about, they accept it, they don't feel threatened by that. It's within their comfort zone. So safety and safe are really the social concepts. And in technical terms, you cannot really measure safety other than through its counterpart, which is risk, which can be calculated. So using the technical terminology, which is expressed in the ISO IEC guide 73, safety is freedom from unacceptable risk, which essentially in practical term means that we realize that whatever we do in life, there's no zero risk associated with safety. There's some part of risk that we accept. And the most easy example to understand, it's, I guess everyone in this fair either have driven a car or was in a car. So when you get either behind the wheel or behind the driver or close to the driver, you accept the risk associated with driving, and we do it every day. So that's within our comfort zone. We think this is safe. So our motivation here, and really what justifies our existence, and what Dr. Jordan alluded to that, is that we would like to be in that comfort zone, in the acceptable level of risk. In other words, whatever we do with hydrogen, we do not add or exceed to the level of risk which feels comfortable and acceptable to people. And because if we do that and we sustain a serious accident, that might be devastating for the industry. It's just like the gasoline that may survive Exxon Valdez or BP collapse of the oil platform out there, because we know that the hydrocarbons are the blood of our business, of our society. Hydrogen fuel cells, the technology is coming in, so we need to be extremely careful from this perspective and getting into these new markets, as we talked about, so that we communicate information and education and training properly, and making sure that technologies are being introduced in these new markets, which were in existence for more than 100 years, are handled in such a way that we stay within this acceptable level of risk. So that's my personal motivation. I think that's the good and noble goal for the HySafe. So if people, say in Germany, as was communicated yesterday by Klaus Bonhoff, feel not threatened or feel very comfortable with hydrogen, it shouldn't be communicating the point that our job is done. No, actually our job is just beginning, and will accelerate the more hydrogen and fuel cell technologies are being introduced to the world. So that's really the mission of the HySafe, to make sure that it happens.
In other words, when you are handling hydrogen, you are still in your comfort zone, yes?
Yes, absolutely.
Okay. Yes, we have. I have just shown quite a couple of activities of HySafe. What would you say? What is the most important now, from your point of view?
Well, you obviously said that the conference is certainly very important, and we'll show a few slides at the end of our presentation specifically, and I will show our brochures. But as Marianne Julien actually commented yesterday when there was a EU Day, that the issue of education, training, and knowledge dissemination are extremely important. We know how to handle hydrogen, but the majority of the public does not, and a lot of experts. So we need to open up, we need to outreach. And from this perspective, our international conference, which is a marquee event, a unique event, is very important, has been very successful. Now, the journal initiative, also very successful, collaboration with the International Journal for Hydrogen Energy, allows us to consolidate the papers that otherwise are spread around into one kind of voice. So that has been a successful activity. And whatever we do to coordinate the research priorities and other educational activities, which we're going to expand, they are very important. Essentially, what you showed is all very important, obviously addressing the industry needs. So we're working on all fronts, growing from the conference and expanding our activities on different directions.
Yes, we both know that the conference is causing a lot of work for us right now. Well, this is quite natural because it will be held in a few months. And okay. HySafe was founded in 2009, and can you tell us a few things about the development of the organization since then? Where are we now, and do you see further progress, or are we on something like a plateau?
I think we certainly see the uptake. When the association was founded in 2009, there were only 19 partners, and they were all from Europe. There was one from Canada, which was original member of the NOE HySafe. So that was the beginning. So it's 2013, and since then we added 14 more members. We significantly expanded the presence from North America, and there are big institutions which are comparable, say, with the Karlsruhe Institute of Technology, like Sandia National Labs or Pacific Northwest Lab. We also have one member from Asia, and that's the Kawasaki heavy industry. So that points out as an obvious direction. We certainly have Europe covered, though we're obviously looking for new members. We have North America represented. Again, we're obviously looking for new members. But Asia, that area, certainly on our radar screen, and that's why we're going to 2015 to Japan, and we will be quite aggressively present in other Asian countries, China certainly, Korea and India.
Thank you very much.
You wanted to ask another question?
Oh, I forgot it.
Well, a good question to ask. Why somebody wants to be the member of HySafe? And it's a fair question. And I mentioned Kawasaki heavy industry, for example. And you would think, why would Kawasaki join hydrogen safety? People mostly know Kawasaki for the world-famous motorcycles. Of course, they do all other things, including, in airplanes. And one of the particular area why they joined is they actually built cryogenic vessels for moving cryogenic liquids. And Dr. Jordan mentioned Fukushima, and there obviously was a lot of paradigm shift in Japan after that unfortunate accident. So the attention to the new energy carriers significantly increased. And hydrogen is playing a significant role in the views of the future of Japan. So Kawasaki Heavy Industries is involved in a new project which would use the hydrogen production liquefaction from coal with a carbon sequestration and moving it to Japan in tankers. So that's it's a totally bold game for them and for the world. We have to look at a very large transfer of hydrogen across the waterways. There are issues with the storage on different parts of the world of liquid hydrogen and safely handling it and distribution. So that's where Kawasaki Heavy Industries sees the value of getting to the pool of experts, global experts that HySafe has to assist them to build a research program that will address their needs and make them more competitive. So that's the reason for the companies that may not necessarily be directly involved in hydrogen safety not to be the member, because they get the access to the information that NOE HySafe had and in the pool of experts. So that's really the motivation for the people to be involved.
So you have heard, everybody whose company is not yet a member, approach Mr. Shuvaev.
Right.
Yes.
We certainly welcome people.
Thank you very much.
All right, thank you.
Yes, to conclude, a few words about the conference which we will have in Brussels in September. The conferences have been held in interesting places so far, and the conference site for the conference in September will be the Charlemagne building, which is in the heart of Brussels and which is normally used by the European Commission. And here you see a look into the great meeting hall. And please don't be afraid. I will not read this to you, and I will not discuss every item in detail. I just would like to tell you that this conference is really comprehensive. It covers the whole field of hydrogen safety, and also fields which somehow are bordering to it. From rather legal matters like codes and standards, over safety solutions and implementation of technologies, to material properties and risk management. And hydrogen and hydrogen safety are a field which has connections to a great number of other fields. For example, during the last conference, which was held in fall 2011 in San Francisco, somebody came and gave a detailed account about the accident in Fukushima and about the role which hydrogen had played there. And this was, I can tell you, was a very interesting thing, because there are many wrong ideas about this too. Yes. If you plan to submit an abstract, I'm sorry to have to tell you, you can't any longer. Here is a statistic of the abstracts which have arrived, sorted after country and sorted after topic. And I think with 146 abstracts arrived, we will be able to fill the time rather well. Yeah. Should you like to know anything more about HySafe, of course you are welcome as a new member. Other questions are welcome as well. Please address either Mr. Shuvelev, who is the president of HySafe, or address me. I'm the public relations man. And, well, if there are any questions or comments left, we are welcome. Myself and my colleagues will do our best to answer your questions.
Can I have it? All right, thanks. I just wanted to note I have printed brochures. If anybody interested, I'll be happy to hand it out in there. I just want to do the topics that we had to point out a few things that, as Dr. Schmidtchen said, hydrogen is connected to a variety of things, and maybe you have noticed we this time included elements like the battery safety and the fuel cell safety, because we understand that, for example, a fuel cell vehicle that contains a hydrogen on board also has other electrical sources. Fuel cells are an obvious one, but the batteries are also there. So we will have presentations on that. Hydrogen safety encompasses many other things. It's not just deals strictly with hydrogen, but other associated technologies, and that's what attracts people to it. Thank you.
Thank you, Mr. Schmidtchen. Does anybody here in the audience have now any questions to one of these guys? No, not yet. So, Mr. Schmidtchen, you are here at the group exhibit until tomorrow.
Yes.
And where can I find you if I have a question or if I like to discuss any point personally with you?
It's very easy. Just on the opposite of this corridor, you will find the booth of the DWV, the German Hydrogen and Fuel Cell Association. And then there you will find either me or somebody else who is competent on the field.
Okay, thank you very much. So give a big hand to all these guys here. Thank you very much for being here to spend your time with us. After a short break, we will continue our program with a topic from the Center for Solar Energy and Hydrogen Research by Merle Klages, and the title of the topic is Advanced Diagnosis Techniques for Water Inventory of Gas Diffusion Layers and Flow Fields at ZSW. Thank you very much.